August 14, 1943. Dust and heat shimmer over the Sicilian plain. Lieutenant Arthur Brennan walks between rows of Sherman tanks at a forward repair depot near Gela. He is a mechanical engineer attached to the 2nd Armored Division. The tanks around him are scarred by combat but mechanically sound, yet their crews are dying. Brennan carries a clipboard and a modified mine safety lamp. He stops at a tank marked Baker 7. The hatch is open. Inside, the crew compartment smells of oil and cordite. He lights the lamp and watches the flame. It burns steady at first, then weakens near the floor. The air is bad. 3 days earlier, Baker 7 had won a fight against 2 German Mark IVs near Kaltagirn. The crew drove their damaged tank back to the depot. By the time they arrived, the driver was unconscious. The gunner and loader were vomiting. The commander died that night in the field hospital. The medical officer listed the cause as heat exhaustion. Brennan knows better. He has seen this pattern since North Africa. Crews finish engagements successfully, then collapse. Some lose consciousness while driving. Others slump over their guns after firing. The symptoms appear without warning. Headache, nausea, confusion, then blackness. At first, commanders blamed the heat. Then they suspected bad rations or contaminated water. No one looked at the air itself. Brennan had joined the division in Tunisia 4 months earlier. His assignment was to improve tank reliability under desert conditions. He focused on engines and transmissions. Then a crew from the 3rd Battalion died in their tank after a night march. All 5 men. The tank had not been hit. The engine was running when they were found the next morning. The division surgeon asked Brennan to inspect the vehicle. He climbed inside and immediately felt dizzy. He backed out and requested a gas detection kit from the engineers. The test showed carbon monoxide at lethal concentration. The exhaust manifold had cracked. Fumes leaked into the crew compartment through gaps in the firewall. The men had sealed the hatches against the cold desert night. They suffocated in poison while the engine idled. Brennan reported his findings to the division commander. He expected immediate action. Instead, he received skepticism. Tank crews operated in harsh conditions. Casualties were expected. The priority was keeping vehicles in the fight, not chasing invisible threats. Brennan was told to return to his engine work. He did not. He began inspecting tanks across the division without orders. He carried his lamp and detection kit from depot to depot. He found carbon monoxide in 2 out of every 5 vehicles. The sources varied: cracked exhaust manifolds, loose gaskets, poorly sealed firewalls. Firing the main gun created pressure waves that forced exhaust back through ventilation gaps. The crew compartment was supposed to be sealed for protection against gas attacks. That same sealing trapped the poison inside. Brennan documented each case. He photographed the leaks. He measured gas concentrations at different engine speeds and firing rates. He interviewed crews who had experienced symptoms. Many described the same progression: mild headache during combat, nausea after sustained firing, confusion during long movements. Some crews had learned to crack the hatches during travel, but this exposed them to enemy fire and shell fragments. They had to choose between poison and bullets. By July, Brennan had compiled reports on 43 incidents. He presented them to the division medical officer and the maintenance chief. The evidence was clear. Carbon monoxide was killing more tankers than previously recognized. Many deaths attributed to other causes were actually poisoning. The problem would worsen as the campaign moved to Italy, where mountain roads and sustained operations would keep crews sealed in their vehicles for longer periods. The maintenance chief authorized Brennan to develop a solution. He was given access to a workshop, 3 mechanics, and a test tank. He had 2 weeks. Brennan started with the source. He inspected every exhaust system design used in the division's Shermans. He found that manifold gaskets failed under sustained operation. The cast iron manifolds cracked from thermal stress. He could not redesign the exhaust system, but he could improve the seals. He sourced high-temperature gasket material from aircraft repair stocks. He specified thicker manifold bolts and lock washers. He created an inspection checklist for mechanics. Sealing the leaks was not enough. The crew compartment needed active ventilation. The existing system used passive vents that relied on vehicle motion to create airflow. This failed when the tank was stationary or moving slowly. Brennan designed a positive pressure blower system using surplus aircraft ventilation fans. The fans drew outside air through filters and forced it into the crew compartment. This created higher pressure inside than outside, so any leaks pushed air out instead of drawing fumes in. The blower system required electrical power and mounting space. Brennan and his mechanics worked through the night, cutting metal and running wiring. They installed the first prototype in the test tank on July 28th. They sealed the hatches and ran the engine at combat speed. They fired the main gun repeatedly to simulate battle conditions. Brennan sat inside with his detection kit. The carbon monoxide levels stayed below dangerous thresholds. The system worked. Brennan needed one more component. Crews had to know when they were in danger. He could not install blowers in every tank immediately. He needed a warning device. He remembered the mine safety lamps used in coal operations. They changed color in bad air. He contacted the Army Corps of Engineers and requested portable carbon monoxide detectors. The engineers had chemical detection tubes used for gas warfare defense. The tubes changed color when exposed to carbon monoxide. They were small, simple, and reliable. Brennan received 200 detection tubes on August 3rd. He distributed them to every tank crew in the division with written instructions. Test the air before sealing hatches. Test again after sustained firing. If the tube shows contamination, ventilate immediately. The tubes gave crews a tool to protect themselves while the retrofit program expanded. The division commander approved a full retrofit on August 10th. Brennan was given 30 mechanics and authorization to modify every tank in the division. The work would happen during a planned maintenance stand-down before the invasion of mainland Italy. Brennan had 3 weeks to retrofit 200 vehicles. He organized the mechanics into teams. Each team could install a blower system in 6 hours. They worked in shifts around the clock. Brennan moved between work sites, checking installations and solving problems. The blower fans drew more power than expected. He had to upgrade alternators in some vehicles. The filters clogged quickly in dusty conditions. He specified a larger filter housing and a cleaning schedule. Some crews complained about the noise. He added sound dampening and adjusted fan speeds. The retrofit was half complete when Brennan realized the equipment was useless without training. Crews had to understand the threat and maintain the systems. He wrote a training manual in 2 days. It explained carbon monoxide poisoning in simple terms. It described the symptoms. It showed crews how to test the air, operate the blowers, and inspect the exhaust systems. It included emergency procedures if someone was poisoned. Brennan could not train every crew personally. He selected one crew member from each company and taught them in groups of 20. These men would train their own units. The sessions lasted 4 hours. Brennan demonstrated the detection tubes and blower controls. He showed them damaged exhaust manifolds and explained how leaks developed. He made them practice the emergency procedures until they could execute them quickly. The training revealed a problem Brennan had not anticipated. Many crews did not believe the threat was real. Carbon monoxide was invisible and odorless. The symptoms resembled common combat fatigue. Some men thought Brennan was inventing work to justify his position. Others resented the additional maintenance burden. Brennan needed proof they could see. On August 25th, he arranged a demonstration. He gathered 50 crew members at the depot. He sealed a tank with the hatches closed and the engine running. He had disabled the blower system. He placed detection tubes at different locations inside. After 10 minutes, he opened the hatch and showed the tubes. All had changed color. The air inside was poisonous. Then he activated the blower system and repeated the test. The tubes stayed clear. The crews understood. The retrofit was completed on September 1, 1943. Every tank in the 2nd Armored Division had a working blower system, improved exhaust seals, and carbon monoxide detection tubes. Every crew had been trained. Brennan submitted his final report and waited to see if the modifications would work under real combat conditions. The division landed at Salerno on September 9th. The fighting was immediate and intense. German forces contested every hill and river crossing. Tank crews spent days sealed in their vehicles, moving through artillery fire and engaging enemy armor at close range. The conditions were exactly what Brennan had feared. Long operations, sustained firing, sealed compartments. The first reports came back after a week. No crew incapacitations from carbon monoxide. The blower systems were working. Crews reported feeling alert even after extended operations. The detection tubes gave them confidence to stay sealed during combat. Maintenance crews found and repaired exhaust leaks during routine inspections before they became dangerous. By November, the division medical officer compiled casualty statistics. Crew incapacitation from all causes had dropped 70% compared to the Sicily campaign. The number of unexplained deaths had fallen to nearly zero. Experienced crews were surviving longer. Tank effectiveness improved because trained crews stayed in the fight. Other divisions noticed. Requests for Brennan's retrofit kits and training materials came from units across the theater. The Army Ordnance Department standardized his blower system design and began installing it in new production tanks. The carbon monoxide detection tubes became standard issue for all armored units. Brennan remained with the 2nd Armored Division through the Italian campaign. He continued to refine the ventilation systems and train crews. He investigated every case of crew illness to identify new threats. His work expanded beyond carbon monoxide to include other environmental hazards, cordite fumes from firing, hydraulic fluid leaks. heat stress in sealed compartments. Each problem received the same methodical approach. Identify the source, measure the effect, design a solution, train the crews. The division reached the Po River in April 1945. Brennan had been with them for 2 years. In that time, the modifications he designed had spread to every American armored unit in Europe and the Pacific. Thousands of tankers were alive because the air they breathed was clean. The invisible killer had been defeated by engineering and training. Brennan received a Legion of Merit for his work. The citation mentioned his technical innovations and his dedication to crew safety. It did not mention the skepticism he had overcome or the nights he spent in workshops solving problems no one else acknowledged. It did not describe the crews who survived, because he refused to accept that men should die from the air inside their own vehicles. After the war, Brennan returned to civilian engineering. He worked on industrial ventilation systems for mines and factories. He never spoke publicly about his military service. The tankers he saved did not know his name. The modifications he designed became standard features, their origin forgotten. The lesson remained. Protection means nothing if it traps the threat inside. The crew compartment was sealed to keep danger out, but it concentrated the poison within. Brennan saw what others missed because he looked at the air itself, not just the metal. He measured what was invisible and made it visible through simple tools and clear training. He gave crews the knowledge to protect themselves and the equipment to survive. The war moved on. The tanks rolled north. The air inside them was clean.